Good morning, Algebra 1 students. Today we are going to be doing 6.1. We're going to be dealing with exponential functions. Yesterday we did a review of exponents and exponential functions, making tables and graphs for different exponential functions. And you will see some of that in today's work. So let's talk about exponential functions for a second. Exponential functions are graphs that look like this. They increase exponentially. So they have a gradual curve, and that curve steepens very quickly, exponential curves. And we see those in everyday life. One of the places we can see it right now is in these graphs of COVID cases. So these are total COVID cases, and you can see we have exponential growth. We started off last year in March with little to no cases, and it grew. So we have this exponential growth, where today we're at 5,158 cases, and in March we were at 1. So, perfect example of exponential growth right there. And there's an example of an exponential function right there, y equals 2 to the x power. All right. Now let's go into our book. Let's look at something like this. If we want to graph this, I would encourage you to use one of the Desmos calculators. So if you use the scientific calculator, we could plug this in, 16 times 2, and we're going to do, so our first problem is the 0 power. So what do we get when we put 0 in here? We get 16, because we know that anything exponent to 0 is 1, so 1 times 16 is 16. So our first one here is 16. And if I go back to the calculator, I'm going to take the 0 out, I'm going to put in a 1, and I get a 32. Then I'm going to take out the 1, I'm going to put in a 2, get 64. Ooh. I'm just seeing a pattern here. Take out the 2, and put a 3, I get 128. Take out the 3, and put a 4, I get 256. Take out the 4, put in a 5, and this is going to double to 512. So if you notice, I'm going up by times 2 each time, right? Times 2. Now, if my difference rate is multiplication by a consistent number, then I have exponential function. If it's multiplied by anything greater than 1, it's going to be exponential growth. If it's multiplied by anything less than 1, I'm going to get exponential decay. All right. Now, same problems. So, let's move on. Let's get a quick reminder as far as exponents go. Remember that. Let's take 5. 5 squared equals 25. 5 times 5 is 25. 5 to the third power, 5 times 5 is 25, times another 5, we get 125. Now what about 5 to the first power? Well, anything to the first power is itself. And 5 to the 0 power, don't forget this is not 0, this is in fact 1. And then we can go into negative numbers. Let's say 5 to the negative 1 is 1 over 5. 5 to the negative 2 power is 1 over 25. There we go. So that's just a little refresher of some stuff that we did yesterday. As you get into negatives, any negative exponent turns it into a fraction. 5 to the 0 power is 1. So don't forget those things. Probably should have put this up on the big screen. Okay. All right. So let's graph this one. So how I would like to see you graphing it is you would log into your Desmos calculator, log into Desmos and in your graphing calculator, and you're going to make a table. And for this table, we need 0, 1, 2, 3, 4, 5. So I have 0, 1, 2, 3, 4, 5. And for 0, I have 16. 1, I have 32. 64. 128. 256. And 5. 12. So I just made a table. I did the work right here. I plugged it into the table, and I now have this graph, which is way up here. So what I'm going to do now, and I don't have any negative numbers, but what I'm going to do now is I'm going to turn this into a line and see what my line looks like. So I can see this exponential growth. It just goes really, really steep. Now, let's say I put a -1 in there. Let's see what a -1 would look like. Or just for sake, let's put in a -3. Oops. -3, and I get 2. -3 is 2. So I go over here. I don't think I can go above it, so I'm going to go -3. And what did I get? I got a 2. And then let's just to get this thing rolling out, let's do a -30. Oops, let's not do that big. Let's do a -6. Get 0.25. -6. I get 1/4. So if you can see this graph is coming down and starts to turn. Why is it too different? So I don't know why I didn't join up here. But anyways, you can see this graph goes and it starts to turn pretty quickly. Okay, so that is how I'm going to ask you to do your homework. So I'm going to ask you to do the table. Do the table, and then put that table into Desmos calculator. Okay, and then you're gonna save this, and you're going to share with me the URL. You're gonna share the graph with me for your homework. Okay, so let's look at down here. Let's check out this one. So here we have an increase. It's ×2. Let's check out this one. So I'm going to go back to here, and I'm going to make this 1/2. And then let's do 0, just like it did, 0. So we get 16. Then we're going to do 1 is 8. 2 is 4. 3 is 2. 4 is 1. And 5 is 0.5 or 1/2. So now what I'm going to do is I'm going to put these numbers into a table. So this would be number 2. Number 2, and number 2 is going to be a table. I'm going to have 0, 1, 2, 3, 4, and 5. So I have 16, 8, 4, 2, 1, 5. Alright, so there's my new graph. If I scroll in, I can see what's happening here is I have exponential decay. So now I'm getting smaller as I go on. I'm getting smaller and smaller and smaller. So this is an example of exponential decay, whereas the other is an example of exponential growth. So if we look on here, this is being multiplied by 1/2 times 1/2 times 1/2 times 1/2 times 1/2 and times 1/2. So what I have here is I have exponential decay. Exponential decay, whereas this problem I have exponential growth. And so for exponential growth, you saw the chart go, or the graph go up, and for exponential decay, you saw it going down. So there's your basics for exponential growth and exponential decay. All right. Now, we come over here, you'll notice that if this number is greater than 1, you're going to have growth. And if this number is between 0 and 1, so if that number, call it b, is greater than 0 but less than 1, you're going to have exponential decay. Exponential decay. So if that makes sense to you, that's great. If your b value is greater than 0 but less than 1, you're going to have decay. And if b is greater than 1, you're going to have exponential growth. Just like that. All right. So let's check out some of these. Let's do some of these, and we're going to sketch some graphs. So what I'm going to ask you to do is you're going to have to make a table for part of your homework. So here, let's make a table. X, Y. So let's see, let's do X is -2, -1, 0, 1, 2, 3. I like those 6 numbers because that gives us a good idea of what's happening. So if I have 2 to -2, that's 1 over 2. 1 over 2 squared, right? So I write it in a fraction. If I have a negative number, I write it in a fraction. So I have 1/4. So this is 1/4. 2 to -1 equals 1 over 2. So that would be 1/2. 0, anything to the 0 power is 1. 2 to the 1 power is 2. 2 squared is 4. And 2 to the 3rd is 2 times 2 times 2. It'll be 4, 8. There you go. Now, you put this table into the graphing calculator in Desmos so that I can see it. Or if you have a graph ready, let's see, we don't have anything less than 0, so we'll start at 0, 0, and we'll, oh, I'm sorry, we'll make this our, we don't have anything less than 0 on our y. So we have -2, 1/4, -1, 1/2, 0, 1, 1, 2, 2, 1, 2, 3, 4, and 3, 4, 5, 6, 7, 8. So there goes our exponential growth right there. Let's do one more. Let's do this one right here. 3 times, actually, let's do a decay. So 3 times 1/2 x. So I'm going to do my same thing. I'm going to have an x and a y. And I want to do -2, -1, 0, 1, 2, 3. So since this is getting pretty complicated, I'm going to head on over to my scientific calculator right here. I'm going to plug this in. So I have 3 times 1/2 3 times 1/2, and I'm going to start off with a -2. So I get 12. And then I'm going to put in a -1. I get 6. I'm going to put in a 0, which will be, to make it 1 times 3 is 3. Then I'm going to put in a 1, 1.5. I'm going to put in a 2, which is 3/4, 0.75. And I'm going to put in a 3, 0.375. So there's my points. Now let's see. We're going to start off at a -2 again. So I'm going to put it like this. So I have -2, 12 is off my graph. -1, 6, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3. Oh, let's make that bigger. 1, 1.5. 2 is 3/4. And 3, 1, 2, 3, is 0.375. So there's my exponential graph right there. That's good looking. It's a good graph. Exponential growth right here. Exponential decay right here. Notice how this is greater than 1. We have exponential growth. This is between 0 and 1. So we have exponential decay. All right. So, mentioned this earlier. But when b is greater than 1, you have an exponential growth. Exponential growth. Now, if I were to have a negative here, a -a, I would have this right here. So this is a positive, negative. Now when b is greater than 0 but less than 1, I'm going to have this decay. What it's doing is it's getting closer. The further up the x I go, the closer to the x-axis I'm getting. The further out the x I go, the further from the x-axis I'm getting. So here's decay. Okay? So that's the core concept. That's how when our x is greater than 1 and our our b value is greater than 0 but less than 1. All right. Let's go ahead and do some of our homeworks. How do we determine whether it represents an exponential function? Well, let's look. I'll do the odds. You can do the evens. And have fun with these. So, first I determine if I have a constant rate of growth on my x, or a constant rate. And yeah, +1, +1, +1. Okay. Now what's happening here? 8 to 4, I'm multiplying by 1/2. 4 to 2, I'm multiplying by 1/2. 2 to 1, I'm multiplying by 1/2. So this is exponential. This is in fact exponential. So check this one out. See if it's exponential. Exponential is when it multiplies by a number or fraction. When it's multiplication, it's exponential. If it's just adding or subtracting, if it's a consistent adding, then it would be linear. So let's look at this one. For number 3, subtract 3, subtract 3, subtract 3. This is not exponential. But for a little extra credit, I'm going to say it is linear because we have a consistent change rate, addition and subtraction here, and this is a consistent +1, +1, +1. All right, give 2 and 4 a try and see what you get. All right, evaluate the function for the given value of x. So we have our x value is 5, so we have to plug that in wherever there's an x. So we have 3 to the 5th. That's 3 times 3 times 3 times 3 times 3. I always like it when you write it down until I am guaranteed that you have an understanding of exponents. So then we can see any problems. So 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. And 81 times 3, let me get my calculator, is 243. So that's my answer, 243. All right, number 7. 3 times 4 to the 4th. My x value is 4, so I plug the 4. So it's 3 times 4 to the 4th, which is 3 times 4 times 4 times 4 times 4. 16. 64. 64 times 4 is 256. So now I have to do 3 times 256, and I get 768. All right. Compare an exercise 8-9 graph the function. Compare the graph to the parent function. We haven't talked about parent functions. Okay, this is pretty. Yeah, let's just do the domain and range right now. So I'm going to graph these by getting my -2, -1, 0, 1, 2. So I'm going to plug these into my scientific calculator because this is a lot. 2 parentheses 1/4 2 to 1/4 to the x value. So my x value is going to be -2. Bring it -1.5. Then I'm going to do, oh, no. I didn't do the exponent. -2. It's 32. Excuse me, I'm sorry. Make sure you put this as an exponent. Do you see how different my answers were? Here it is -2 as an exponent. And then here it is just -2. So make sure you have it as an exponent. So -2 is 32. -1 would get me to 8. Zero would get me to 2. 1 would get me to 0.5. And 2 would get me to 0.125. So I take those answers and plug them in. So we're going to do -2 again. -2, 32, that's off the charts. -1, 8. 1, 2, 3, 4, 5, 6, 7, 8. 0, 2. 1.5. 2 and 1/4. Or that's not 1/4. It's 125,000th. There goes my graph. All right. Moving on. Here's one thing to note. This is a neat fact. This number is my y-axis. I'm sorry, my y-intercept. This 2 is my y-intercept. So there's my y-intercept, 0 and 2. Because if this was 1 times 2, so where I have my 0, 2, this is my y-axis. It's kind of cool. All right. Graph the function. Oh, graph domain and range. Domain and range. So for my x values, this will keep going forever and ever. This will keep going this way forever. It will get so close to the x-axis I can't tell the difference, but it will never cross the x-axis. But it will keep going on forever. In this direction, it will keep going on forever and ever. And I mean, it almost seems infinite by the time it gets out here. But my domain, which is my x values, domain is infinite. That's all my values. Now my range, which is my y values, well, my lowest y value is 0, right? It can't be a negative y value. My lowest is 0, and my highest is infinite. So my range is 0, y is greater than 0. Y is greater than 0. That's my domain and range. Okay, number 11. F of x equals 4 to the 1/2 times x plus 1. Ooh, fun. So, let's take this one. And we will go f of x equals 4 times 1/2 and then I go up for my exponents and I go x plus 1. So if I'm going to make a table for this one, I have x and y. I'm going to do -2, -1, 0, 1, 2, 3. So if I put in my exponents, since it's x plus 1, let's put a -2 in there. So -2 plus 1. Oops. -2. Oh, how did I lose that? I guess I can't put a plus 1 up there. So what's -2 plus 1? -2 plus 1 is -1. So I get, for this one, I get 8. Now don't be confused that my equation says -1, but what it is it's -2 plus 1. So I have 4 times 1/2 times -2 plus 1. Well, that equals -1. So my -2 value is 8. And then if I have -1, -1 plus 1 would be 0. I have to make sure it's in the exponent value, 0. So the -1 is 4. And if I have an x value of 0, that would mean that this is 1. 1. So it's 2. And then 1, if I plug in x value of 1, that would be 1 plus 1, so that would be 2. So if I have 2, I get 1. And then if I have 2 plus 1, I get 3. So 2 plus 1 is 0.5. And then 3 plus 1 is 4. So we get 0.25. So trying to get confused in there, it's a bit of a mess, but in the end, you get your table. If you would like to plug these numbers in the Desmos calculator and just say number 11 and show me the graph in Desmos, that's totally fine. If you would rather not, do it here. 2, 8, 1, 2, 3, 4, 5, 6, 7, 8. So -2, 8, -1, 1, 2, 3, 4, 0, 2, 1, 1, 2, 1/2, and 3, 1/4. So there is my graph, my domain, which is my x values, is all numbers, and my range, which is my y values. Y is greater than 0. All right. So, I think we are, let me show you this one, and then if you put these numbers in a table, you'll be able to answer for these ones. So I'm going to show you how to write an exponential function from data from a table, and then just put this data into a table, and you'll be able to see how to do it. So, what's our change value here? We got 1, 1, 1. So that's good. What's our change value here? 3 to 18, that's times 6. 18 times 6 is 108. So that's times 6, and that's times 6. So what we have is, write this down. F of x equals a times b to the exponent x. And what we have is a equals our y-intercept, and b equals our rate of change. Rate of change. So, our function equals, where's our y-intercept? Our y-intercept is here at 3, right? We have 0, 3. So our y-intercept is 3, and our rate of change is times 6. There you go. You just wrote an exponential function based on that data. So take this, make a table, and if you want to make a table the same way, you do your x's and your y's, or your f of x, and you write them in. And I would go in order. So start here, put 0, negative 0.5, then put negative 0.5, negative 1, and you're going to put negative 1, negative 2. Oh, this is getting ugly. And then you're going to put negative 1.5, negative 4. And your rate of change of here is consistent, plus 0.5, plus 0.5, plus 0.5, or minus 0.5, minus 0.5, minus 0.5. You know what your A is, and your B, let's see, just go from 0.5 to negative 1. That would be, you multiply it by times 2. That would be times 2. And that would be times 2. So our change value is 2. And you tell me what your y-intercept is, and then write your function. Okay? There you go. Go ahead and try number 14 also. Your homework is to do 1 through 14. And I hope it makes sense.